So the first piece of this is finding the term of an annuity. So remember before when we were looking at this, we had just our basic annuity timeline. We have A sub n here. Regular payments start 1 period later. We have end payments, and then at the time of the last payment, that's our S sub n. So all we would do is we would use our regular AN or SN problem, and then we would find N. So it's the same process. So we're going to go ahead and work out number 1, and then we're going to jump to do the new stuff with this problem, because it's the same problem just in different pieces. Okay. So in example 1, an amount of $10,000 is borrowed at 6% interest compounded monthly. So right here, this is borrowed. Because it's borrowed, it's at the beginning. So we already know that. And then it's monthly. Okay, and if the loan is paid off with monthly payments, so here they match. Not a 3-4 problem because they match. If they didn't match, then we'd have to deal with either the effective interest rate, the EIR, or we would have to work with, something similar. So here again, they match, so we don't have to worry about that. And then our payment is $300, and it begins 1 month later. So put that on our timeline, $300 1 month later. So then our second payment would happen at the 2-month mark. And we want to know how many monthly payments are needed. So we're trying to figure out what N is here. And again, our interest rate is 6%, so 0.06. And that's compounded monthly. So that means I is 0.06 over 12. And now we're trying to find the 10,000. So again, we have that beginning 1 month later, and then it's borrowed. Those two pieces tells us that this is an AN problem. So we know that AN is going to be the 10,000. And that's equal to our 300, our R, times 1 minus 1 plus our I, so 0.06 over 12 to the negative N. That's what we're trying to find, over 0.06 over 12. Okay, so we're trying to find this whole bit. Now we've done these types of problems before, but now we're doing them with the A sub n, S sub n problems. So because it's with the A of n or S sub n problems, they look a little different, but the process is very similar to what we were dealing with in section 2.4. So first thing we do is we have to get this whole piece alone, so we divide by our 300. So we get 10,000 divided by 300. And that's going to be equal to our big fraction, 1 minus 1 plus 0.06 over 12 to the negative n all over 0.06 over 12. So now we're going to multiply this over because we have to get rid of the fraction first. So we have 10,000 over 300. And again, if you wanted to cross off some of these zeros, you totally could. You'd cross off this one and this one, say. So you could write it as 100 over 3 to make it a little easier. Again, it's totally up to you. I'm more concerned if you know what's happening and you know how to solve it. Okay, so then we're just left on the other side with that numerator. Okay, so I'm going to move the 1 over because I want to get the thing that's raised to the exponent alone before I apply my natural logs. So I have 100 over 3 times 0.06 over 12 minus 1 equals negative 1 plus 0.06 over 12 to the negative n. Now we have a negative on both sides, and before we raise each side to the n, we want to get rid of that negative. So I'm going to grab another color just to make it more obvious that everything is flipping signs. So we're going to make this a plus, and then this piece would be a minus. So again, everything is flipping sign. Move this up a little bit here. And now we're ready for the natural log step. So we're going to take the natural log of 100 over 3, negative 100 over 3 times 0.06 over 12 plus 1 equals negative n, because I'd pull down this whole piece when I take my natural log. That's why you had that review problem. Okay, so then to get n, we're just going to divide by the natural log of 1 plus 0.06 over 12, and that's going to be the negative. So then n is going to equal negative natural log of 1 minus 100 over 3 times 0.06 over 12 all over the natural log 1 plus 0.06 over 12. So entering this in our calculator, we need to be careful. Okay, so I take a negative first, and then I'm doing natural log, and now I'm going to put this whole bit in my numerator, so 1 minus 100 divided by 3 times 0.06 over 12, and my I, and my natural log, and then I'm dividing that by another natural log, 1 plus 0.06 over 12. Every time you find n, you should get something positive, okay? So what this means is, because we have 36 and then a fraction, means that n is 36.55, okay? This means that we're going to make 36 full payments and 1 smaller payment. Okay, because when we're talking payments here, the amount can change, but the number of payments isn't going to change. Okay, so we're making 36 full payments and then a smaller payment. Okay, so now we're going to use this information to flip over to part B, finding the concluding payment. Now when we find the concluding payment, there are 2 different ways that we can deal with this. So big idea again, we have P, okay, that's our principal or our loan amount, whatever we're dealing with. And then we're going to have our regularly scheduled payments R, just like any ordinary annuity or loan that we take out. So this would be your A sub n over here. Just connecting it to what we already know, okay? The big idea here is when we're trying to find the concluding payment, whether it's at the time of the last full payment or it's, you know, 1 payment period after the last full payment, it's always, everything's going to be moved to the end. So our focal date is the end, just like in merchant's roll, connecting all of that together. Okay, so we're moving all the money to the end. Okay, so that would be your future date. Future date. So you're moving it this way. So we're going to move all these down. We're going to move this one down, all the way down. Okay, so we have, again, 2 different pieces here. Okay, so at the time of the last full payment, our formula is going to be including payment. Okay, I abbreviate this as CP sometimes. You don't have to. Your book just calls it formula 4.1 and 4.2, which I find confusing. So this is going to be P times 1 plus I, whatever your interest rate is, to the N. So again, we're going to taking into account all the payments, minus S sub n. Okay, so again, S sub n comes back. And then if we're doing it 1 payment period later with a small concluding payment, so 1 payment period later, this would be your smaller payment. Okay, all we have to do is we're going to move these 2 things forward 1 period, so we're really just multiplying this whole thing by 1 plus I, but we can use a separate formula. So it'll be P 1 plus I to the N plus 1, because it's sitting there for 1 extra payment, minus SN due, because remember, the only difference between SN and SN due is just the 1 plus I. You can look at that on your formula sheet if you need to. Okay, so again, we're using the numbers from problem 1 to find the size of the concluding payment, so if it's made at the time of the last full payment. So just as a refresher, I'm just going to redraw the timeline just so we have a visual. So we had $10,000, and then we made a payment of $300 for months. So we had 1 month later, 2 months later, and then this was at the 36-month mark. Okay, so there's going to be some left over because it doesn't take 36 payments. Okay, it doesn't take 36 payments. So we're going to make it at the time of the last payment. So that means this payment isn't going to be $300. It's going to be bigger than $300. It's called the balloon payment. Okay, called the balloon payment. So then right here, what we're going to do is, I kind of call this the leftover formula, so you can call it the leftover formula, or again, you can just do concluding payment. It's totally up to you. Okay, but the leftovers after 36 payments would be your 10,000, that's your loan amount, times 1 plus 0.06 over 12, so that's our I, to the 36, because that's what N is, minus our regularly scheduled payment, because now we're doing S of N, 1 plus I to the N, so 36, minus 1 all over 0.06 over 12. And then we would just plug that whole thing in the calculator. And again, you can do it in one shot. You don't have to do any extra work here. So I'm going to go ahead and scoot this up just a bit. 10,000 times 1 plus 0.06 over 12 to the 36 minus 300 times, so this first set parentheses my numerator, the second set is my 1 plus I, 1 plus 0.06 over 12 to the 36 minus 1 over 0.06 over 12. So we get $165.97. Okay, and you could round that up because it's a payment, but it's going to depend on the bank you're working at what they're going to do with that fraction of a penny. So we're just going to go to 2 decimal places around to the nearest penny here. And then we're going to add this to our regular payment. So the balloon payment is going to be the leftovers plus the regularly scheduled payment. So in this case, we'd add this to 300. So we're going to do 165.97 plus your 300. So then the large concluding payment, that 36th payment, is going to be $465.97. Okay? Now, if we were to wait a month and make that payment the next month instead of trying to swing all $400 at once, you know, say for some reason these borrowers just couldn't afford that, that's okay. They can do that, but they're going to have to pay interest on that leftovers. Okay? But again, I'm going to use the new payment, or the new formula from up here, okay, this one, just to make sure that we see it. Okay, so it's going to be the leftovers, 1 month, so that's our payment period, okay, is the month, after the last payment. So it's the same formula, real similar. So I have 10,000, and then 1 plus 0.06 over 12. Instead of, this is a 1, instead of 36, we're going to use 37. Okay, and then instead of SN, because this is our SN problem, this whole bit right here, now we're going to have SN due. So it's going to look the same. We just have that 1 plus 0.06 over 12 at the end. Okay, now looking at this number should be bigger than our other leftover number, but it's going to be smaller than the total balloon payment, so you need to be careful there. Okay, so in our, just going to scoot this up so you can see what I'm doing on my calculator and still see the formula. So what we can do is, instead of retyping the whole thing, is you can use your previous entry. Use your previous entry and then just change the exponent. So I changed this 36 to a 37. This one's going to stay the same, and then at the end we're just going to add 1 plus 0.06 over 12. So then our money is $166.80. So again, we're going to round to the nearest penny here because it's going to depend on the bank. Okay, so if you wanted to pay off that loan at the end, at the same time as the last full payment, so you don't pay that extra dollar or whatever in interest, you could do that by using a balloon payment. Otherwise, the concluding payment is paying after the last full payment. So this is your concluding payment. So concluding payment is the smaller one. Okay, so go ahead and try number 2 and number 5, and then when you're ready, click on the next video.